Now on the Chapter 2 test, one of the things that you really needed to look at was the graphs of the parent functions before you take the test. So this page, I think, came from the 2-4 notes, if I'm remembering correctly. And I just want to talk about it for a minute, okay? So if our power is a positive odd, so it looks like this or this. So the power is 3, 5, 7, 9, 11. It will always look like a cubic. Now, this is if the front is a positive coefficient like this one. Here is if it has a negative coefficient like that one. Okay? If the power on a power function is a positive even, like a squared, a fourth, it will always look like a parabola. Positives, coefficients, just pop it to the pointing upward. Negative coefficients go downward. Now let's talk about as soon as they become negative. As soon as they become negative, that really refers to division, and so you get a gap at 0. So negative exponents should immediately tell you you have a problem at whatever the 0 is. And so if your front coefficient is positive, you will have pieces in the first and the third quadrant, like this one. If your front coefficient is negative and your power is an odd negative, it will flip upside down. Okay, so you've got to remember, negative odd powers are like our traditional rational function from Chapter 1. Now, if it's a negative even, what happens is, because an even power squares something, it takes both pieces and either flips them up if the front coefficient is positive, or flips them down if the front coefficient is negative. Okay? So negative exponents have that gap. Please remember that. Now, fractional exponents, like we see over here and here, fractional exponents, remember, are going to act like either square roots. One swoop to the side, it goes upward if it is a positive coefficient, or downward if it's a negative coefficient. And that is if you have an even denominator. So it's like a square root, a fourth root, a sixth root. So these would be fractions like 1/2 or 1/4. As soon as your exponent is a fraction, now these are positive fractions, negatives always look like these things, but if it's a positive fraction and the bottom is an odd numbers work, negative numbers work for the odds, and so you get not only that swoop in the first quadrant, but you get a matching swoop in the third. Now the green one just is because we put a negative in front and it flipped it. So if you don't have this paper anywhere, take a second and take a screenshot of it, and definitely make sure that you understand those. That will be very helpful when you take the test. Okay? Any questions about that before we look at the practice test? And I will have you turn this into Google Classroom. Give yourself a few points. Okay, so I would like to do some problems here from the practice test. That wasn't part of your assignment for the review, okay? And there are the solutions in a PDF copy down here, but let's just talk about the review. So let's start with problems 1 and 2. It says graph and analyze each function, domain, range, intercept, and behavior. We'll do all that. Okay, so let's start with problem number 1. When I see that this is a negative number, I automatically think of that rational function that has those two pieces. And then you want to check, is that positive or negative? Well, is that even or odd? And it's an odd. Now check the front coefficient is positive. And so I know, without plugging any points in, without using decimals, whatever, that this looks somewhat like that. Now, it might be stretched a little bit, squished a little bit, but it's going to look like that. Now let's talk about answering all those things. Okay, the domain for a rational function, that's a parent power function, is every number but 0. We had to skip 0. Remember, there is an asymptote smack dab in the middle because 0, if I flip it and get like 1 over 0, or in this case 0.25 over 0, that is an undefined value. The range also skips 0. There is an asymptote right there. This one approaches 0 and this one approaches 0 for the end behavior. And so the range is exactly the same thing. Let's talk about intercepts. Intercepts is where you hit the x and y axis. There are no intercepts for this graph. The end behavior are these far left and right ends. In this particular case, the ends go to 0. It's continuous along the domain, so the continuity and domain are the same answer. Last thing, increasing or decreasing. If my little math bug starts over here, he is going to go downhill. That coincides with this piece here. So I know that piece is a decreasing piece from negative infinity to 0. Now the domain gives us other hints. See, this piece right here matches this piece. And if you look, if I start here and start walking, I am again going downhill. So I am also decreasing from an x value of 0 to an x value of infinity. Any questions about number 1? Okay, let's look at number 2. Number 2, I see a positive fraction. So a positive fraction looks either like that or possibly some version of 2 pieces. This particular function has a fraction in the bottom that its denominator is an odd number. So that means it has 2 swoops, not just one in the right-hand side, but it's going to have one to the left. This one's a unique one because this 4th power here actually makes both pieces go upward. So the graph looks something like this. And so sometimes for many power functions, I will try to plug in positive 1, negative 1, and 0 to get a picture. And so if I plug in positive 1, I'm going to get 8. If I plug in negative 1, I'm also going to get positive 8. And that's why it swoops upward. And it's all because this 4th power makes the negative a positive. So let's answer all the questions. The domain goes from negative infinity to positive infinity. Nothing screws these up because it's a cube root. You know, this is technically the cube root of x to the 4th. That's how those are converted. The range is everything from 0 up, so that's from 0 to infinity. This matches the continuity. Let's see. There is an intercept. There's an x-intercept at 0, 0, and a y-intercept at 0, 0. Increase and decreasing, last thing. Oh, end behavior. The ends are going up, 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 up. So both ends I could write to them, are going to positive infinity. So let's do increasing or decreasing. So if I start over here and start walking, I'm going to go downhill and I'm going to go uphill. So there's this change in height at 0. So I am going to go downhill or decrease my height from negative infinity to 0. And then I'm going to increase my height from 0 to infinity. Okay. Any questions at all about what we have so far? Okay, now we're going to do some of these equations right here. Let's do this first one. Let's do number 3. So for problem number 3, we see a radical in our equation. It's a square root. That kind of will change your thinking a little bit. And so we want to always isolate whatever kind of radical we have. So we need to move this 8 to the other side. So we get x plus 8 is the square root of 4 minus x. Now, in order to free that x from the square root, you got to square both sides. So that means surround the entire sides by parentheses. So the right side, the square root and the square are opposites, so they cancel out. But the left side, that really means x plus 8 times x plus 8. And so you physically have to FOIL. So that's going to be x squared plus 8x plus 8x plus 64. Now that's a quadratic. Most quadratics, most polynomials, most everything we do, it's helpful to solve it by getting it equal to 0. So I don't like these two pieces over here. So let's subtract 4 from both sides and add x. So when you do that, you get x squared. I have 16x already. When I add x, I'm going to get 17x. And then 64 minus 4 is 60. Now I need the factors of 60 to add up to 17. Doesn't 12 and 5 make 60? Let me check. Yeah, 12 times 5 makes 60, and so 12 and 5 are where I want to go because 12 and 5 are going to add up to that 17. And so I get values of negative 12, or negative 5. Now, here's the thing. If our values are negative 12 and negative 5, you have to check these. You have to. Because a square root can get messed up by negatives. So how do you check them? Well, we're going to check them back in the original. Okay, so first let's check negative 12. So that's negative 12 equals the square root of 16 minus 8. Well, that's negative 12 equals 4 minus 8, which isn't a true thing. So that one's gone. Now let's plug in negative 5. Negative 5 is the square root of 9 minus 8. Negative 5 is 3 minus 8. Hey, that's a true statement, so that one works. So please, if you are solving a square root equation, you definitely want to check it. Anybody have any questions about number 3? Okie dokie. Let's move on to some polynomial stuff. Let's look at 9 and 10, because those are pretty cool. It says, describe the end behavior graph of each polynomial function using limits. Explain your reasoning using the lead term test. So I don't worry about the limits. I just want you to be able to describe the end behavior. Okay. So let's look at number 9. The lead term for number 9 is our highest power term, or 5x to the 4th. So we know from what we discussed at the beginning that an x to the 4th goes straight up. So what's the end behavior? Well, the left end goes to infinity, the right end goes to infinity. Let's look at 10. The lead term for 10 is negative 3x to the 5th, which is a cubic that has been flipped upside down. So, because of that, we could say for our end behavior that our left end is going to positive infinity and our right end is going to negative infinity. Any questions about 9 or 10? You guys are so quiet. Hopefully that means you understand everything. Let's look at 11 and 12. It says state the number of possible real zeros and turning points and then find all the real zeros by factoring. So I would like to just do number 11. So based on the fact that our lead term is 4x cubed, I know that since the power is 3, the most zeros I will ever have is that same exact degree, 3. And the turning points, the most, will always be 1 less than that value, so 2. And then they want me to find the zeros by factoring. So I notice that every single one of these pieces are divisible by 2. Oh, divisible by 4. And have an x in them. So let's take a 4x out of all of those. And so we're left with x squared plus 2x minus 15. And then that's a factorable quantity. Just take and break down 15 so the factors subtract and have a difference of 2. So that's x plus 5. Oh, and x minus 3, because 5 times 3 is 15. 5 minus 3 is 2. And now how do we find the zeros? We're going to set each piece equal to 0. And so we get 0, negative 5, and positive 3. Any questions about number 11? Okay, let me check here. Now I would like to do problem number 16. Okay, so let's look at the instructions. For each function, apply the lead term test, find the zeros and state the multiplicity of any repeated zeros, find a few additional points, and then graph. We're not going to do much maybe about the few additional points, but we will graph them. So we know, let's write down everything we know. The lead term is x to the 4th. So I know the ends are going to be pointing up. If you check, this is a factorable quantity. I can factor out an x squared. This piece here is the difference of squares, so that's going to be x plus 3 and x minus 3. So I have zeros of 0, which has a multiplicity of 2. See, because of the fact that there's a square on that x, and then negative 3, and then positive 3. So we have everything we need to graph it. So over here at negative 3 we have a 0, 0 we have a 0, and positive 3. The left end's going up, the right end's going up. But we have a bounce occurring at 0. So we have to go through this one, come up to 0, bounce off, and come back up. So this one looks kind of like a W. Okay? Any questions about 16? Okay. I'm just looking. Let's do number 17 now. That's a good one. It will be a good review. Okay. So for 17, it says, use the factor theorem to determine if the binomial given are factors. Use the binomials that are factors to write it in factored form. So if x plus 3 equals 0, if it is a 0, which we hope, that would be great, then negative 3 is the thing that caused the 0. So the first thing you want to check is plug in negative 3 and see what happens. Well, you plug in negative 3, you just, all the x's, put them in parentheses, and it becomes negative 3. So what do you get? Well, you get negative 27 minus 3 times 9 minus 13 times negative 3 plus 15, which is 0. So yes, it's a factor. Now, they said if we find that it's a factor, they want us to actually factor it out. take it out, so that we can break up 17. And so I'm going to use synthetic division. I'm going to put negative 3 in the corner. Now let's check our polynomial. It goes 3, 2, 1, nothing. Perfect. So write down your coefficients. 1, negative 3, negative 13, and 15. Set up your box. Okay, so our box is set up. Now let's go ahead and do the math. Now remember what we're going to do. We're going to multiply, write it down, add it up. Multiply. That is not the multiplication of that. Wait a second. Okay. Negative 3 times negative 6 is 18. So that's a 5. And then 5 times negative 3 is negative 15, which is a 0. Remember, we should get a 0 in that corner. Okay? So this was an x cubed. So this now becomes an x squared. So our factor, or taking out that factor of x plus 3, led us here. And luckily for us, we can write it in factor form one more time. That's not right. So that would be x minus 5 and x minus 1. So we know the factored form of f of x is x plus 3, x minus 5, and x minus 1. So if they say factored form, that's what they're talking about. If they say zeros, the zeros are negative 3, 5, or 1. Any questions about that one? Okay, let's go back up. Let's see what else we got. So we did that one. Okay, I would like to do number 20. Now let's do 20. Yeah, let's do 20. I'm going to talk about both 20 and 21, but I'm only going to do 20. So if we look at 20 and 21, it says write a polynomial function of least degree with real coefficients in standard form that has the given zeros. Now, in 20, I see a square root. In 21, I see an I. Square roots and i's always come in pairs. So the fact I only see one means I need to add the conjugate. So for 20, I also have a 0 of positive square root of 3. And in 21, I also have a 0 of 1 plus I. Now remember how we write this polynomial. It's going to be x minus the 0 times x minus the 0. You're always subtracting off your 0. And however many you have is how many you write. So for 20, that would be x plus 1, x minus 4, x plus square root of 3, x minus square root of 3. And then you're going to just multiply using FOIL and using distribution. I would suggest multiplying those ones first. Now let's talk about 21 for a minute. How would we set that one up? Well, that's going to be x minus 5, x plus 5. Now we're going to subtract both of those, so we have to change each of them. So that's going to be x minus 1 plus I. That's for this one. See how it's minus 1 and plus I. And then the last one's going to be x minus 1 minus I. And then for this one, I would definitely FOIL those together and FOIL those together. So your last goal would be multiply all this stuff out. Any questions about setting up 20 or 21? Okay. Don't care about 22. We know about synthetic. We're good there. What I would like to talk about now is, let's do 25 and 27. I know we're getting late, but I wanted to do one of each. So let's do 25 and 27. So 25 says to determine asymptotes, intercepts, and graph it, state its domain. Let's go over here. Oh, that didn't work. Just a minute. Let's try this again. So we're doing 25. Okay, so the first thing I told you to do is to put it in factored form. It is in factored form. You don't have to, oh, well, we can take out a 2 here, I guess. Second, look for any holes. A hole occurs if a factor on top matches a factor on the bottom. It doesn't, so there are none. Third step, vertical asymptotes. That's where the bottom equals 0. So that's at -5. Fourth thing, domain. Well, the domain, we take out any holes in any vertical asymptotes. There's only one at -5, so we got to skip it. So we're going to go up to -5, skip it over, and keep going. So because the domain has 2 pieces, that tells me that my graph is going to be in 2 pieces. Next, intercepts. The x-intercept is where the top equals 0. So 2 times x minus 3 equals 0 when x equals 3. The y-intercept, we're just going to plug 0 in and go for the best. So it's -6/5. So -1.2. Okay. And then 6, we jump in and graph. So you really want to follow every rational function you see, those 6 steps. Okay. So let's put on everything we know. Okay, there is a vertical asymptote at -5. We hit the x-axis at 3. Oh, I didn't do horizontal asymptotes. I knew I was forgetting something. We hit the x-axis asymptote at 3, or x-axis at 3. We definitely need to do the horizontal asymptote. Oh, I'm so sorry. We'll get there. -1.5 or 1.2 was our y-intercept. Let's put on our horizontal asymptote. I'm so sorry, I forgot that. The horizontal asymptote for this one's kind of a neat one because the lead term on top is an x to the first and the lead term on the bottom is an x to the first. We use those coefficients. So it's 2/1 or 2. So let's put that on there. That's going to definitely help our graph. And so what we get a piece here. And then I think, but I'm not sure, we'll get a piece over there. Well, how do I make sure I'm sure? Well, I got to plug in -6 minimum. So if you plug in -6, you get -12 minus 6, which is -18 on top, and -1 on the bottom. 18/1 is 18. So it is a number way, way up there. It's off my chart, but it is. It's going to be a piece going up. Here, at this end has to follow that asymptote. This end is following that asymptote. So there is 25. And I know I'm holding you over, but let's do one more. Let's do 27. Just so then we've done together one of kind of each little piece. Okay, let's go 27. To solve an inequality, you want to relate it to 0. After you relate it to 0, you want to put it into factored form. If it can't be factored, so this is a factorable quantity, which is great for us. So this is x minus 7 and x plus 2, because 7 times 2 is 14, 7 minus 2 is 5. So remember what you do. Set each one equal to 0. Solve. So we have 7 and -2. We're going to put that on the number line in least to greatest number line order. Now we're going to look back here. If there was an equal to, we would close in the dots. Since there isn't an equal to, put it open dots. Okay. Now we're going to turn this into a chart. We're going to put x minus 7 over here and x plus 2 over there. And in any order, it doesn't matter. And we have to get some test values. Something to the left of -2 is -3 on the number line. In here, I always choose 0 if I can. And then let's go with 8. Okay, now we're going to plug them into each of these and see if we get a positive or a negative. So if we plug -3 in here, it's a negative. Two negatives make a positive. If I plug in 0, I get a negative, a positive. One negative is a negative. If I plug in 8, I get a positive and a positive, which is positive. And I want less than 0. That's the negatives in here. So how do you write that as an answer? Well, I want to answer all the answers from -2 to +7. So I know that was quick, and I know we did a lot. Hopefully that gets you thinking about the stuff that's going to be on the chapter test. Please, 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 please do this review with your Ed puzzle. And I think if you study those things, you're going to be ready to go. So please join me on Tuesday's Google Meet, and I'll send you and email you the test. Any questions before we say goodbye? Okay, you guys, thank you so much for hanging out with me for this long, and I will talk to you again on Tuesday. If for any reason you need between now and then, if you have any questions, please feel free to ask, okay? Bye, you guys. Have a wonderful week.